Today I'm going to be showing you PC-DMIS Vision. This is the same PC-DMIS that runs on all of Hexagon's product lines, including our tactile systems. Vision was implemented into PC-DMIS about 6 years ago, which allowed us to incorporate all the CAD capabilities and benefits of PC-DMIS with a Vision sensor. We are able to upgrade a wide variety of Vision systems with PC-DMIS Vision software, but today we'll be doing a demo live on our own Vision system, the Optiv Performance 443, which you should be able to see in your upper right corner. The Optiv is a multi-sensor system, which uses Vision, touch probe, and a chromatic white light used for non-contact scanning. You might also notice on this system that has dual Z-axis, which move independently. This way, the contact and non-contact sensors can be separated, allowing measurement of larger parts without the fear of collision. We also offer a rotary table, which allows measurement 360 degrees around the part. So, for those already familiar with PC-DMIS, the main difference when using Vision is the addition of the Live View tab. The Live View shows the actual image that the camera sees when performing the measurements. Today I'm going to start with the manual tools. Manual tools were implemented so that we can walk up to a system and do quick, simple measurements without making a program. Many people are accustomed to using optical comparators or microscopes. These tools allow you to use the Vision system in the same way. So in order to do this, we're going to start off and open up our probe readouts and switch over to the Manual Tools tab. Over here in the Live View, you'll see a crosshair. I can now grab it, drag it to an edge, zero out on the direct readout, and then move it to another location. Here I'll be getting the answer directly from the probe readout, simple, easy measurements. Another example would be the circle gauge. Hang on one second, I have my poll question in my way. We're going to move the circle gauge to the center of the screen, size it to the appropriate diameter, and now you can see the diameter of the gauge directly on your Live View. If you should happen to know what the diameter should be, we can type in directly into the dialog and set the gauge to be an actual diameter. Other examples of the gauge diameters or the manual tools would be a rectangle gauge, a protractor gauge, a radius chart gauge, or a grid chart gauge. All these you can move around, manipulate, and take your measurements direct. Now whenever you're doing measurements, you can always save the Live View image. So we go do a screen capture to a file, name it a file name, and we'll save this image as a bitmap. This way, if there's a part defect or other problem, you can send the actual image via email to those concerned. Right now I'm going to switch over now to automatic measurements, and we'll start programming directly from the Live View. So we'll close the probe readout, and down in our auto feature toolbar, I'm going to select a circle. In the Live View, I can double click next to the feature. You're going to see that the target will automatically show up. This is represented from the two red lines. This now sets what your area of interest is and where PC-DMIS is going to look for the edge. So now I'll hit test. You can see the green dots where PC-DMIS detected the edge. You're going to see that there's some spaces here on the edge. This is because most of the parts that we measure are small and very difficult to clean. PC-DMIS employs outlier filtering so that dust and burrs are not used in the calculation of the feature. Now another great feature is the calibration of the lighting. PC-DMIS calibrates all three light sources, your backlight, your top light, and your segmented ring light. This has two main benefits. First, since light bulbs, wiring, voltages are not constant, the brightness of a light on one system may differ from another. By calibrating the lights, you assure, for instance, that 30% is the same brightness across all your multiple systems. This way, when transferring programs, you don't have to edit the lighting on every feature. The other benefit comes when it comes to editing features. If I come in here, for instance, we'll change our target slightly, change my magnification to maximum, PC-DMIS will automatically change my lighting, change my targets, and now calculate all the new positions in order to measure the feature. So I'll hit test, and now you can see it will automatically go and measure the circle just by changing the magnification. It makes editing a lot easier to do without having to manipulate all the different features of the vision measurement. So once this gets done, another thing, if you want to do a focus, let's say you have variability of your parts. In PC-DMIS, I just have to go to that feature and turn on the focus directly. Now I'll hit test. In the case of a feature outside your field of view, it will do a focus on the first position and measure the rest of the circle at that Z location. There we go, it's finished. Right now I'm going to switch over to the CAD view, because the CAD view is the basic benefit of using PC-DMIS itself. When we look in the CAD view, I'll zoom in, you can see this green triangle. This represents the field of view of the camera. The CAD when programming in PC-DMIS is live, so I can come in directly onto this green box. Let me switch over to the Meg over there. And move the machine directly within the CAD view. So you can see down here now, the machine moves with the CAD. I have a little flickering going on here due to the connection, but I can move the system anywhere I want. The other thing I can do is actually grab the corner of my live view and change my magnification directly within the CAD as well. So now let's measure a feature using the CAD. Let me zoom out for a moment. We'll go to the circle, and now I'm going to click on the CAD. As you can see, the target shows up in the CAD view as well. If I move the system over to that location, it's also in my live view. I can edit this target within my live view as well as the CAD view. Once again, we'll go to the live view and do a measurement. And also in the CAD view, we'll change the magnification. And test again. And once again, your setting, your lighting, your targets, and positions are all automatically calculated. Now remember, as we're going through this, you can ask a question at any time. You can also tell me that I talk way too fast, so feel free. We're going to go real quick. The one thing with measuring large diameters is the fact that it takes a lot of positions to measure them. In order to speed up the process, we can actually come in and say, I only want to measure 30%. Now when we hit test, we're only going to do certain segments. This speeds up your measurement time dramatically on very large features, and very easy to do since I don't have to manually block it out. Now the other reason for using multiple hit targets, so we'll change out, go back to 100%. We'll go back to our CAD, is if you have a circle diameter that's broken, for instance, and we'll zoom out and come into this. Let's say we want to measure this diameter. As you can see in here, there are breaks within the circle itself. Let's do this one more time. We'll hit move to, and now we can see it in the live view. Zoom out, and now we can see it in the live view. If I hit test, you can see that there's going to be areas I don't want to take a measurement. But due to our outlier filter, we're still taking these points out of the equation. But for instance, if you really didn't want to do measurements in these locations, I can manually insert hit targets and tell it not to measure points in those areas. Once again, I can do this within my live view, or go to my CAD view and insert hit targets there as well. We'll do the same for the last two positions. And point density of none. Now when we hit test, PC-DMIS will ignore these areas that we don't want to take measurements. So let's switch this back once again to 100%. Go back to our CAD view. The other thing, for instance, if you have a CAD model and have multiple features that you want to measure, like a series of small holes, PC-DMIS in the CAD allows me to do a box select. So in this case, I'll select all 12 circles. As you can see, we found the 12 circles. When I hit create, PC-DMIS will program those and now go measure them. This time when you see it, you'll actually see that it's actually measuring multiple circles at the same time. We call this multi-capture. PC-DMIS is smart enough to realize that multiple features fit in the field of view at the same time. That was pretty quick, so let me run that again to give you an idea of what we're talking about. So when you come through and actually have a feature or a part that has a lot of small features, instead of taking 1 second per feature, you now do 5, 6, 12, as many features that fit in your field of view, which really reduces your cycle time. We'll give you another example of this. Let's go back to our CAD view, and for instance, let's measure some lines. Come over here, once again, I'll box select some lines. In this case, I found 12. We hit create. PC-DMIS programs them and measures them all simultaneously. Another common measurement that you do with Vision is doing profiles, where you go and digitize the edge and then compare it back to your CAD model to get a vector chart. I'll show you real quick how we can do that. First, I select my 2D profile. On my CAD, find the edge, for instance, that we want to do the profile on. Box select the appropriate curves. We found 40 curves. Hit create. PC-DMIS sets up your targets and the positions, and we'll go and measure them. Once your edge is digitized, we can now go over to our exact measure GD&T functions. Here I'll select my profile, set up my feature control frame so it looks like my print, tell it that I want the graphical analysis on, and hit create. Now if we go back to our CAD, you can now see that we have a vector chart where the blue lines are going to represent your tolerance bands, and the little vectors here, varying in color, will show you the degree of deviation of your points back to the nominal. One of the last things I wanted to show you a little bit has to do with our edge detection capabilities. So we'll move over to a line up here. So let's change our edge. Most cases when you're using Vision, using your backlight makes it very easy because it's a black and white edge. Trouble comes in when you start using your top light or your ring light, because now you have varying degrees of grayscale. Most systems are going to come in and actually measure from one side to the other, looking for a change in grayscale. Because we have varying differences in grayscale, if I do a test here, you can see I have points all over the place. I'm not getting to the edge that I want. So instead of using specified edge, which is a common technique on Vision systems, we have other edge selections that we can choose from, like dominant edge, nearest nominal, or even matching edge. Matching edge in this case is a weighted algorithm saying, I know that I'm looking for a line. So instead of just looking for a change in grayscale, it's looking for the pixels that make the best fit line. So in this case, when I do the measurement again and hit test, you can see that all the pixels line up on the line that you want.